Welcome to reInvent 2024. I hope you all had a chance to catch Matt's keynote this morning and the exciting announcements we made regarding our GenAI foundation model. Today, we have a really interesting panel discussion set up for the folks here. We have some industry leaders who are going to discuss how they developed their foundation models and how they're looking to innovate and deliver to their customers. I'm Shubha Kambatkone. I'm a senior manager in our GenAI org at AWS. I lead go-to-market for our SageMaker HyperPod service, which is a differentiated GenAI infrastructure offering. I'm joined here today by Jeff. I'll let all of our panelists introduce themselves, so why don't you go ahead, Jeff?
Happy to start. Hi, everybody. I'm Jeff Boudier. I'm a head of product at Hugging Face. Hugging Face, our mission is to democratize good machine learning, and I'm excited to tell you more about it.
Wasim?
Hi, everyone. My name is Wasim Al-Sheikh. I'm the co-founder CTO at Writer. Writer is a generative AI platform for enterprise, and our mission to transform work for enterprise. We're proud to be leading platform for the more than 300 enterprise company in healthcare and financial services.
And Robert?
And I'm Robert Backus. I'm co-founder and CTO at Hopper. We're building foundation models in medical imaging and a medical grade platform to be able to support inference for those models.
So before we get started with the panel discussion, I want to kind of quickly provide an overview of what HyperPod is and what it delivers. How many of you in the room today are looking at building out your own foundation models or are in the process of figuring out how to kick off your GenAI model production? Right. And what are you looking at? Are you looking at building out your own model? Are you looking at fine-tuning existing open source models? How are you kind of thinking about it? Fine-tuning? Got it. But you are looking at training over, a couple of GPUs across a couple of nodes and looking at how to architect that out. Is that right? Got it. So a lot of the customers we talk to who are looking to do exactly what was just said, which is fine-tune models or even build their own foundation models, typically they have certain key considerations. If you kind of think about what are some things that are top of mind for them, one of the first things is the data. Like, how ready is my data to train my model? Is it labeled? How differentiated is it? Do I have enough data to actually train my model? If not, where can I get or gather all of this data source from? What kind of data am I using? Is it just text? Is it multimodal? How does that impact my storage and file systems that I need to choose for my training? The second is how much GPU horsepower do I need, or how much accelerator or compute horsepower do I need to actually train this model? Depending on how large the model is, how much your data size is, how many GPU hours are you looking at, and what kind of GPUs do you really need? Do you need the H100s? Is the A100s enough? Do non-GPU solutions work? All of these are things that customers are figuring out to kind of understand what is the cost and what is the time that it will take them to actually get to market. And of course, as they think about spinning up these hundreds to thousands of accelerator compute clusters, how you manage this cluster, how the scaling efficiency works is also important. If you're doubling the number of GPUs you're using to train your model, does that translate to double your training performance? If not, how can you actually improvise your training performance? And how do you manage your compute cluster? If you have hundreds and thousands of GPUs, how are you doing your job submission? How are you making sure your cluster is utilized at least close to 100%? And what does your cluster uptime look like? And that directly comes down to what is the resiliency or the infrastructure resiliency of your cluster. How often are these GPUs failing, and how much time are you spending, are your data scientists spending trying to analyze what has failed versus actually innovating and building out the model itself? We heard a lot of these concerns from our customers, and working backwards from them, we designed and built SageMaker HyperPod. It was launched last reInvent, and since then it has seen some really good traction with customers. It's really resonating because it is purpose-built for distributed training. It is resonating with customers who are looking at launching training jobs across hundreds of GPUs, or maybe even less than 100 to tens of thousands. We are able to cover easily, scale up and scale down the size of the cluster that customers need to actually train their models on. What does HyperPod really deliver, and why do we say it is custom built for distributed training? It enables your data scientists to get better training performance. And by that, I mean we provide a persistent cluster that is on a single spine. So we are able to immediately reduce the networking overhead that is required because of the forward and backward passes that your distributed training will require. And having all these nodes optimally co-located in our data centers and providing them to you as a cluster will immensely improve your networking speeds. We also provide support for any distributed training framework that you want to use, whether it's FSDP, DeepSpeed, or any other choice. We also provide proprietary SageMaker distributed training libraries that provide performance enhancements over PyTorch. And so if you're fine-tuning Llama, fine-tuning Mistral, you can actually get performance enhancements by using these proprietary libraries. But if you do not want to, and you want to kind of continue using what you have used so far, you have that flexibility as well. The most important value prop of HyperPod is the resiliency. And why is resiliency so important? If you think about the scale at which a lot of this fine-tuning happens, even a single failing GPU will stall your entire training job, which means that you are spending cycles trying to understand what caused your GPU to fail. Was it an application error? Was it a memory problem? Was it a thermal issue? Was it a really bad node that needs to be swapped out and replaced? You're spending a significant amount of time analyzing that versus what you actually want to spend time on, which is your model development. How does SageMaker HyperPod actually address this issue? We do some deep health checks of the nodes as your cluster is being spun up. So as your cluster is being created and as your cluster is being updated, we do health checks and we replace the bad nodes. When your cluster is up and running, we have agents that are continuously monitoring node health. And if we detect a faulty node, that is a node that has failed, we can automatically swap that out with a warm pool of healthy nodes. And you can then kick off your training job from the last checkpoint that is saved in an S3 bucket, or you have the option of letting us do that automatically for you. Now, it's important to note that this resiliency benefit is actually what a lot of managed services deliver. When you have a failing node under the hood, managed services will automatically take care of it for you. But managed services also provide a layer of abstraction away from the infrastructure. And for most advanced ML users, they want that control or the deeper level access to the infrastructure. And by that, I mean being able to SSH into the nodes, being able to do nickel testing or DCGM testing. They want that level of visibility. They want to be able to use any open source tool and framework and library that they opt for. And they want to be able to have a deep visual profiling and visualization of cluster and GPU utilization, as well as tools to see what's going on with their cluster. HyperPod allows you to do that. So while it is removing the undifferentiated heavy lifting of infrastructure resiliency management, you continue to use the compute, the networking, the frameworks, the libraries. All of that control is still very much in your hands, and you're able to actually build out and optimize performance as required. You do get root access to all the nodes. You're able to do your nickel testing as well as your DCGM testing, and you're able to look at cluster utilization and monitor your cluster by using container insights through CloudWatch. Like I said, we also provide our proprietary distributed training libraries for data parallel and model parallel training. So any optimizations you want over FSDP, you can get them by using these proprietary libraries. So to kind of wrap it up, what HyperPod delivers is a way for customers to really innovate their foundation model development. You can customize your compute, use the range of GPU and non-GPU-based instances that AWS delivers. You can choose the tech stack that you want to use. You have a persistent cluster that you can use across your workloads. You're able to SSH into the nodes, have that root level access, have all of the control and flexibility that you want when you're building out your training architectures, as well as your inference architectures, and have an easy way, continue to use Slurm or Kubernetes to orchestrate as well as submit your jobs. That means your existing tools and your existing technology stack does not have to change. You can continue using your tools of choice, and then you can use model recipes that we have published to easily kick off or spin up these clusters and get going with minimal overhead. With that, I want to now turn it over to our panelists. And let's start with you, Jeff. Why don't we get the audience familiar with how you're looking to innovate for 2025 and beyond. Hugging Face is a well-known brand. You've done a lot for the GenAI community. What are some of the things that you want to innovate in 2025 and beyond?
Thank you. Thank you so much. And before I talk about Hugging Face, I want to give a big shout out to our friends at Writer.ai. Because when people ask me of what would be the great example of an AI-first company, I'll always use Writer.ai because they're doing all the things that enable them to maximize their impact. The first thing is open science. They do state-of-the-art research, pushing the limits of what's possible, and publish some great papers. The second thing is open source contribution. If you go to Hugging Face and find the Writer organization, there's the Palmyra family of models. I think over 14 models that are freely, publicly accessible on the Hugging Face hub. I think they were downloaded over 10,000 times just last month. So it's amazing impact. And on top of that, they build amazing added value into their product, into the features that they provide to their customers. So it's a really, really great example. And I'm so glad to be on this panel with you. I started my introduction by saying the mission of Hugging Face. So our mission is to democratize good machine learning. And by good, I mean based on open source, community-driven, and built from ethics-first principles. And we do this in different ways. We do this through open science. I'm going to talk a little bit more about that. We do this through open source. And we do this through our products and services. So that means the Hugging Face Hub. If you work with open models, you've probably gone on the hub to find, explore models and assess them. There are over 1 million models today that are available on the Hugging Face Hub for any kind of machine learning tasks. Over 7 million people are building their own AI with the hub publicly, but also privately. There are over 150,000 organizations that are built on the hub to collaborate around models. Open source, you're probably familiar with the Transformers library, and there are over 20 different tools text generation inference, to deploy models, data sets, accelerate, and many more. But I want to talk more about the open science because that's something that's really, really important to our mission. We want to be able to contribute to the community new foundational models where there is a gap of performance between what the best closed models offer and what is available to the community. And to do that, we leverage HyperPod. I can talk a little bit about how we do that if you want, or we can do that later.
We can definitely touch on that later. I want to go a lot more deeper into how HyperPod is kind of helping you build these new models. But I want to now go, because you started off with Writer, I want to kind of go to Wasim and have him talk about what Writer's charter is. Jeff touched on your Palmyra LLMs. How are you building that? What are you trying to accomplish for your customers?
Yeah, sure. Thank you. Thanks, Jeff. So when we started Writer in 2020, we started from the day one under the mission to help enterprise transform work. That means basically how AI can really help them. When we start seeing this clear stages, it's like we're going through between 2022, 2023, and 4. And basically, we're trying to say we're starting Writer, we've been building those models, and with every year, bigger models, more capabilities, and we're seeing more and more advancement. Now, every time we build the bigger models and more complexity, complex structures, you're going to actually get bigger challenges. So touch really quick in HyperPod, for example, help us a lot for our latest models. So we have our latest models, this is Palmyra X4, one of our frontier model exists today. The best functional calling model exists in the market today. Basically, to build it, we use HyperPod for this. Now, why that's important there? Because what the change happened in our mind for building those models when we start to scale them, we went from change like, can I build a model 1 or 2 billion? Sure, 1 node, 2 node, not a big issue. The biggest challenges start happening with us when we start building those models at a few hundred billions. At that stage, it's not just the technology and the knowledge, you need hardware to be actually reliable, not failing. So to build on top of this, how we're seeing that our vision and we're building, we're doubling down on actually building better models, more complex models. We're a big believer on not just bigger parameter models. We think parameters of the model itself is not useful. It's contain only knowledge. We're a big believer to call the deeper models. Just what we keep our model today in a few hundred billion, not trillions, outperform a larger model because we're going way deeper in the layers. More than 500 layers in the model itself, which is you see another reason. Now, to do that kind of training, you'll need actually something reliable, not just, it's a GPU cluster, all the same, it's running. You need to make sure training is keep running and the training continue, especially when training could actually take 3 months to 5 months per models. And any failing there actually could really cost a lot of effort, team, and actually implementation. Now, big part also, just to touch really quick here, to build all of this, HyperPod help us a lot, but also the biggest help we get, it's the open source community. So, I'll go back to you, Jeff. Without having this amazing open source community, especially with Hugging Face, sponsor it, it's been hard for us to actually innovate. Whatever we built today and any innovation is coming, especially the latest thing we announced 2 weeks ago, something called self-evolve models. It was actually just built on top of all the open source scientists, paper, model, and data exists in the market today.
Interesting. And Robert, Hopper is in a very, it's in healthcare, you're looking at diagnostic imaging. How are you looking at building your foundation model, and how much of the open source community are you kind of leveraging to build your models?
Yeah, so we're building, as you know, medical image data, or as you may know, medical image data is very large data. It's painful to work with. And obviously you need, because we're training on 16-bit high resolution images, often our models need to be able to consume multiple images at once. We need to be able to leverage the compute infrastructure that HyperPod offers. That's one, that's really been a big boon for us in the services that, that AWS has been able to offer there. needing to be able to move this data, within these clusters, really, at scale, is really critical for us. We are using we have our own proprietary vision transformer that we're working with, and as well as leveraging open source language models to build essentially a multimodal image to text models that allow us to be able to identify the features in medical images and be able to output those in various forms through text, whether that's a preliminary radiology report, a list of findings in the study, or being able to output segmentation masks, for example, and bounding box representations through XML. So a number of different approaches that we're taking there, and leveraging the power that that HyperPod offers has been just a big boon for us in being able to really optimize for the large data that we really have to work with.
Got it. And thanks for sharing that, right? So Jeff, coming back to you, you mentioned how you're looking at science models and how you want to bring more to the open source community compared to closed models. Let's double click a little bit more on that, right? Like, what are some of the things that are like key concerns as you're building out these models from a data side as well as from the infrastructure side? Like, what are some of the, as you build out these models, what are some of the things that you are thinking through? And would love to kind of then tie it back to how HyperPod is addressing a lot of those requirements.
For sure. Yes, as I said, the main goal of our open science team, our researchers, is to close the gap between the best available open models and closed models. And so back in the world of GPT-3, together with the community, we built Bloom. That was at launch the best fully open multilingual large language models, 175 billion parameter. Later, after Codex, our team, along with the community, built the StarCoder family of models, which at launch were the best available fully open models to do code. Later, our science team built Edifix, IDEFICS, which is a family of models which at launch was the best open available model for multilingual LLM tasks. And more recently, just a couple weeks ago, our science team released a small LM family of models, which again at launch are the best open available models at this size. So really the goal is to close the gap, but we didn't always have HyperPod. And I remember the days of Bloom, so that was like 2 to 3 years ago. When you innovate on the science to find a better model architecture, like that's science, but what makes the science real is the model checkpoint that you can find and use and download on Hugging Face. And doing that is not a science job. It is a hardcore engineering job. And when we built Bloom, there was like 1,000 researchers that came together to contribute to this project from every organization in the world, but the engineers that were actually holding the cluster together during the training of Bloom was a very, very small team. And the lead engineer for that was Stas Beckman. And Stas wrote actually a book on his experience, an open source book, it's on his GitHub, where he tells the tales and all the learnings and insights that he learned through the pain of the Bloom training. And the good news is that now with HyperPod, like, we don't need the book anymore. Because all of the pains that we had to go through, they're sort of productized and offered as a service within HyperPod. And so when I talk about Edifix, when I talk about small LM, this leverages our internal science cluster that is managed by HyperPod. And there are a few of those features which you briefly discussed that are critical for us to basically have this cluster being in autopilot mode, so to speak, to provide better insights to the users. The users are our researchers. And to allow us as a business to have more flexibility in how we use the cluster. So things like we have a pretty big CPU partition. By pretty big, I mean like 48,000 vCores That is pretty much in autopilot, leveraging spot instances as we go to scale up and down. We scaled up our cluster up to 1,000 GPUs. And through the access to the low-level metrics, we are able to have smart GPU management, so that whenever some kind of issue arises, we can make the decision to either isolate the node and restart it, or to keep the node and heal it. We also have access to metrics that we can build up for our researchers. For instance, something that we care deeply about is the CO2 consumption through these training jobs. And we've instrumented it so that as a user of the cluster, I can have not only metrics about the GPU utilization and the performance, but also about the CO2 consumption of the job at hand. And flexibility is also important so that we can reconfigure the cluster pretty easily, depending on all the jobs from our research team and even beyond.
Got it. And how has some of the, you mentioned scaling to thousands of GPUs. How has some of the automated resiliency capabilities that HyperPod has kind of introduced helped your overall training experience? Can you kind of comment?
Yes, I think like the first thing that comes to mind is GPU utilization. And that comes at the GPU level to make sure that you don't have faulty nodes that just sit around and not being self-healed. But that's also at the cluster level to make sure that we're utilizing the resources as the jobs come in. So if you zoom out, that means like much better GPU utilization overall for the cluster.
Got it. And Wasim, you also have trained on HyperPod.
Yep.
And I believe you have a couple of data points that you would like to talk about as well. Do you want to also kind of share your experience on how HyperPod has helped with these, as you start scaling your model, and you mentioned going from 1 to 2 billion to hundreds of billions, how HyperPod has really helped with some of that?
And I think the biggest things since we start experiment and then start actually using in real training, using HyperPod, the biggest shift, like not just help with scaling, implementation, we need a smaller team to use it, is the thinking how we manage actually cost and how we think about actually resource allocation. Before HyperPod, simply would always just think about any kind of training clusters in one thing. It's a GPU, who's going to give me the cheapest? All of us actually going to be DGX cluster, similar speed, H100, same infra connections. But that changed with HyperPod, because in HyperPod we start having more visibility about actually something way more important, especially at scale, which is basically resilience and stability. Usually before HyperPod, the way we've been thinking about it, my cost of training will be the cost of the cluster, plus another 60 to 70% of actually of the cost itself, because the cluster could shut down, the hardware failure is going to happen. Actually, this one thing nobody talking about is fail a lot more than you think. I think I believe the Llama Facebook or Meta AI team in the Llama model, I believe the last one they talk about it a lot. How the cluster failed, I believe, if I'm not mistaken, every hour or so, with the one GPU's failed. So going back to our thinking, just help us to change how we think about it and how we think about our cost. So eventually what we start actually seeing, just calculating real cost, is not just the GPU price. It's still important to have a good price on it, but it's the cheapest price compared actually to resilience and stability, way more important. When you kick the job, it's not just a job actually, you could lose the whole work. You could actually need people, if you work across multiple time zones, to wait for a few hours to someone fix the node, replace the node, and doing it. Now think if all of this actually just happening and you're not worried about it, system can actually monitor it, especially again when you run it as more than a few weeks to few months, one job, one models. This is bunch actually data we've been running internally. So basically, first we're starting with a setup. If you talk about simple clusters like a few hundred nodes, at least you will need, 72 hours. Bigger cluster will take way longer, just to connectivity, configurations, make sure every node have the same versions, software versions, same operating system, literally same libraries across those nodes is actually, it's be interesting. Stuff related to what's called automation, the whole thing just end-to-end build it. One thing actually is not in the slide that worth mentioning here. Usually when you're running training job, we will need at least team of 4 to 6 AI ops engineers, just literally babysitting the cluster, monitoring those GPUs and those nodes. In HyperPod, just change it. Now, literally, I have one engineer, he just looking at it, will do everything. We rely a lot on automation, so auto checkpoint, we'll save them, the auto healing, replacing that bad node, all of this just AWS take care of it, and from our side, we're literally sitting there just absorbing and monitoring the process if there's no big issue with the code or training itself. So meaning now I just free another 5 to 6 engineers literally to help with other tasks in the company. So just that thinking of the cost and how you actually allocate resources, that help us a lot, and this actually coming to how we think about it from infra also. Now, how we going with the infra, how we can scale our model, how many replica do we need, how many nodes we allocate. This is stuff start thinking, changing our thinking, and also help us more from budgeting. Because this is basically the biggest spend we have today at Writers, the GPU clusters. Building those models, serving those models at the scale for enterprise customers, billions of token every day across customers, stability with the high availability. You will need a lot of GPUs. Manage them, and someone with the team require a lot of resources. Again, our team today across multiple time zone, it's been hard. So switching to someone like she could be managed end to end, that actually been big win for us.
And do you use Slurm, or do you use the Kubernetes version of HyperPod?
We use a Slurm for now, and we're really excited about the Kubernetes, which is we think that we're going to utilize the Kubernetes HyperPod for inferences. This is going to be big for us with the next generation of the models, something we touch about it, what we call self-evolving models. It's a new type of transformers, full attention mechanism, that actually have a memory layer with each transformer layer. So meaning customer today, they can have their own model that actually learn real time from the action with the models, and those models still can be safe and isolated in the Kubernetes clusters when actually relying on the Kubernetes security to secure the network for each customer and each model around it. So today is a Slurm, and with the planning for inference to scale more with the Kubernetes HyperPod.
And how, you mentioned now you have one engineer who's, instead of like a team of,
So for each training job, today we'll allocate one, maybe two, but usually one engineer compared to full team just babysitting the cluster.
Right.
Yep.
And have they been able to leverage all of the profiling tools and the visualization tools to get a clear understanding of how the GPUs are being utilized, and how has that kind of helped? Because you're significantly scaling down your team, but it also means that there's that much more visibility that person has to kind of monitor performance.
100%. So now, because this visibility, not just for the ops team, also help our scientists and research team. Because now you have visibility about utilization and what type of, when and which level of training, the pre-training or the post-training utilization or issue or actually scaling, especially when you have a large amount of data. Because by the end of the day, those cluster is not just a GPU. You still have a CPU and RAM and storage. You need to monitor all of them. So having a tools give you full visibility. So when the ops team can actually see everything, can it trigger and automate everything, putting some kind of events to triggers in real time, help a lot. Also at the same time, now our research team is actually partnership with the ops. They have a tool they can actually work and monitor and work with them. It's not anymore, it's like, it's bare metal cluster, we cannot touch it, we cannot see anything. We have a DevOps on site managing and babysitting the cluster. This is changing to one person actually seeing 100 of those nodes, sometimes more, and you have the research team actually partnership with them, looking at all the data, all the monitoring.
And moving on to you, Robert, you mentioned 16-bit images, right, and high-resolution images that are required for your model. How has your training architecture on HyperPod kind of helped address that data challenge that you have?
Yeah, so one of the, sorry, I'm speaking too loud. One of the biggest challenges that we have is that we need to use fairly large instance types because we need to make sure we have 80 gigabytes of GPU memory or above to be able to accomplish what we need to accomplish. And so, as you may know, access to those instance types is challenging. It requires coordination, lead time to get AWS to be able to prepare those, 24/7 billing. And so once we're doing that, we're leveraging the cluster for a significant amount of our operations, essentially. Anything that's using GPUs, we're almost exclusively using the entire cluster for. We've installed Docker, Jupyter Hub on the cluster. We do a lot of our experimentation on the cluster itself. And so it's a really flexible tool that allows us to be able to install the tools that we need on the cluster, be able to use those GPUs in the optimal manner, and depending on what that workload is, whether we're running large-scale training jobs or we need to have some of our researchers running experiments on just a couple GPUs within the cluster. So that's been it's a really flexible tool that allows us to be able to do whatever we really need. And these are challenges because of the types of data that we need to kind of deal with. We do have to have access to those fairly large GPU instance types. So it's been it's really flexible. It's been a really powerful tool.
And how have you kind of looked at distributing or sharding your data across these GPUs because of the size of the data set that you're dealing with?
Yeah, we have, so we actually have installed our own distributed file system on the cluster itself. We've also used FSX, but we've had some issues with performance on FSX. So, the power of this is that you can get down, as low level as you need to be able to install the tools that you need. So having that, customized distributed file system has really allowed us to be able to optimize the way in which we're storing data across the cluster to be able to, optimize for our workloads.
And so I'm going to now double click a little bit more just on the kind of distributed training techniques each of you have kind of implemented. This goes a little bit perhaps, on how you can do so across all these accelerators on HyperPod, as well as any kind of new innovations in those techniques itself that you're experimenting with. So again, starting with you, Jeff, what are some of the sharding techniques that you've used? What are some of the libraries that you have actually worked with? And any best practices that you can share with the folks here today?
Yeah, I can share better than practices. I can share the library. So we built a library called Nanotron to make it easier to run large-scale trainings, and it's a little companion, Light Eval, which is an easy way to run evaluations. The sort of type of training techniques that we use really depend on the project that the science team embarks on. So I talked about Bloom, that was a 175 billion parameter model. Small LM, I think we went down to under a billion parameter, like 175 million parameter for the smallest one that's for the smartphone. So depending on the job, like we have very different requirements in terms of how many GPUs for how long would we need. And so the flexibility that we have in HyperPod to sort of isolate job and only use exactly the resources that we need is very helpful.
And what about you, Wasim? How have you looked at your distributed training techniques? What libraries have you used? How did it work?
We've been using a lot of libraries, so it's not like each generation of our model actually been touching using different type of libraries. PyTorch is a lot of utilization. Using Nemo Megatron, one of the actual implementation we use to build and train those models. And this is the beauty of HyperPod. Like we don't have the limitation of what type of software or library you want to use. We can go, as we mentioned, it's very low level to install and but install your, you guys did install your own file system, right? Which is the cool part around it. So you're not limited to very high level when you tell you like this is specific SDK or specific way to build it. So definitely give us a lot. So for example, the latest model, we have our own implementation. We should actually coming open source soon. We have a paper around it, something called a frugal transformer. As a system using KV cache, managed KV cache between the layers itself of the transformer layer itself. So even as a very, very custom, it was a piece of cake to actually run it on HyperPods. We did not have any limitation around this. It's the same thing when you're running stuff using PyTorch or an older model we utilize a lot of Nemo Megatron libraries. It's been actually working just very straightforward without any challenges. And I believe this is going to continue because the open source community is coming with a lot of amazing things every day. And having flexibility from the hardware side to change and utilize any libraries without any limitation, because the speed of innovation is so amazing in the open source community, it's actually key for any tools. Like the idea of you need to be a very strong opinion how you use specific hardware and specific libraries, it's going to be hard to utilize, at least in our side.
And Robert, like, how have you kind of looked at your distributed training libraries? How did it work with HyperPod? Any engineering effort that was required to get it kind of going?
Yeah, within HyperPod, it's been fairly easy. When we've been using DeepSpeed. We're primarily using DeepSpeed and PyTorch. We're currently implementing FSDP for another of the models that we're working on. It's from a HyperPod perspective, it's really easy to get up and running. You can install whatever libraries you need. Like I said, you can get as low level as you need to get, and you really have full control, which I think is that's a really powerful feature that as you really, when you're working at this scale with this type of data and these type of GPUs, you really need to be able to optimize for your workflow, and you really have to have the capabilities to turn every knob. And so, ultimately, I think we found quite a lot of flexibility. Haven't really had a lot of the challenges that we had. Even with some of the previous iterations, like the SageMaker training had a little bit more limitation. So, really happy with the move to HyperPod there.
And we've talked quite extensively about training, but after training comes inference, and that is where there are a different set of challenges, right? Scalability, throughput, latency. And I'm going to start with you this time, Robert,
Sure.
just to kind of mix things up a little bit. How are you thinking about deploying your models? And tell us more about how you're architecting that out, and what are some of the considerations there?
Yeah, so medical images, as you may or may not know, often contain many images. An X-ray, for example, like a chest X-ray, for example, usually contains at least 2 images, frontal and lateral. A 2D mammogram will have at least 4 images at 4K resolution each. And so, you really need to be able to be able to optimize the way that you leverage the way that you leverage the. Sorry, my brain is. I'm gone blank. You really need to be able to leverage the cluster, really efficiently. And so, what we've done is we are Oh, shoot, I'm sorry. I'm trying to play. Can you repeat the question real quick?
It's really about how you're thinking about using the HyperPod cluster, because it is a persistent
Yeah, for inference.
cluster
Gotcha. Yes.
across
Sorry.
training and
Sorry.
inference. Yeah.
Yeah, so for inference, we are, right now we're using SageMaker endpoints, but we can only support up to two images. And so because of the type of instance types that they support. And so we are really looking at HyperPod as a much more scalable approach to being able to do inference on more than just those two images, to be able to support 4 images, 10 images at a time, to be able to perform the inference that we need to. And ultimately, we're looking at possibly building out our own queuing mechanism on top of that. We haven't quite gotten to that point. We'll be kind of launching here in Q1. So haven't gotten it out the door just yet, but that is kind of the approach to be able to make this more scalable for more of those images.
And it's also important, if it is a persistent cluster and it is existing GPU capacity that's available, to be able to kind of leverage it for both training, and once you're done training, to also leverage it for inference, really helps kind of optimize the resources and the carbon dioxide emissions and everything else, right? Like your general TCO of utilizing that infrastructure. So Waseem, how are you kind of looking at building out infrastructure? You did mention EKS for inference. Any specific things that are top of mind?
I put it in this way. One of my engineers, he said, I think HyperPod going to make one of our dream come true, which is running model in Kubernetes. We've been trying this for years. We've been, before actually we start using the existing technologies came from AWS, we've been relying on literally bare metal or just a standalone server to run inference. I'm not sure if you guys have experience around running larger models on Kubernetes. It's not the best experience, especially how you actually scale and auto-scale those models, the GPUs inside the Kubernetes across multiple nodes. It's actually really, really tough. So the solution that the SageMaker team came up with, how basically take the powerful side of Kubernetes when you can actually have the networking, the isolation, the auto-scale, but also linking this with HyperPod to manage actually those accelerated GPUs. It's been actually very, very seamless. This is something we've been looking forward to implement it. We are actually today in the process figuring out how we start doing the migrations. Because in inference, it's not just the time for first token in models. It's not just the processing itself. Especially in enterprise, there is stuff matter like number of requests per second. How many concurrent requests allowed to be utilized. The speed in general between those models. Sometimes also stuff related to availability and, and making sure the SLAs go above 99%. Utilized from there. So this is basically the nice solution when you can really think about it more like a serverless, but it's still Kubernetes. You still can see it how much utilize and how you implement, which is get to the second part, was more surprising. My CFO, actually, Roger, he loved it because now can look at the stuff like, actually my cost, my margin, how much actually we can think and help our customer to think about the cost and scaling. We see a lot of customers care less about basically how many tokens per day, and they care more about how many concurrent requests in a second, and sometimes vice versa between them. And all this help us actually serve our customer in a better way.
And Jeff, are you currently using your HyperPod cluster for inference, or are you planning to?
So today we have our science cluster that's really focused on training, and we have a production infrastructure where a lot of the inference that happens through Hugging Face is, and it's all managed with Kubernetes things like Hugging Chat. It's like an open source ChatGPT you can use for free. Things like the Inference API. I mentioned 1 million models available on the hub. You can try them all right there from the page. Things like inference endpoints if you want to deploy dedicated infrastructure for any of the models hosted on the hub, including your private models. But for us, inference is very important to the mission, and by inference and mean the ability for customers to deploy within their own infrastructure. So maybe if you use some of the models available on Hugging Face, on AWS, you probably use our deep learning containers. We build and maintain deep learning containers so that you can use any Hugging Face model out of the box in an environment that works to do any kind of training and inference within your own tenancy. And that's really important because we don't want to live in a world where a handful of companies are sort of controlling all the experiences that every single company or user has. A lot of our everyday experiences are already powered by AI, and that's only going to accelerate if there's only a handful of models behind all this. That creates a whole lot of issues. The world that we want to live in is one where AI is very much decentralized, and it is within the abilities of every company to build and host their own models themselves. And it's only if you can build and host your own models that you can really control your customer's experience, that you can really protect the customer's data. Often the GPT models behind APIs, they change from one day to the next. You won't be aware of it, but all of a sudden your customer experience changes, requires you to send customer information through the internet to a third-party provider. So there's a whole bunch of issues that I think the industry will be reckoning with. And it's very important for us to provide a wide variety of options for companies to be able to host their own and control their own AI. A recent example of that is Hugs. So Hugs for Hugging Face GenAI services is a new service we launched just a few weeks ago. It's on the AWS Marketplace, and you have an optimized out-of-the-box deployment for the most popular open models that you can host in your own AWS tenancy. But to go back to your initial question, what's interesting to us is that HyperPod gives us flexibility in how we want to utilize the cluster. So it would be possible for us to be able to use the capacity that we have in the science cluster when the training jobs, the training workloads from the science team would not utilize it fully, and dedicate that in a very dynamic way to add to our production infrastructure.
Right. And you just mentioned Marketplace, as well as some of the other, avenues through which the AWS Hugging Face partnership is kind of active. I wanted to kind of touch on how has partnering with AWS as a cloud service provider really benefited in Hugging Face's mission? How has it really helped you reach that faster or helped strengthen your position in the market?
It's a very synergetic collaboration because through our collaboration with AWS, I mentioned the SageMaker deep learning containers that you can all find and use to deploy and train Hugging Face models. But we also collaborate with the team that builds the new Trainium and Inferentia custom AI accelerators. I think earlier this morning, Trainium 2 was announced. We're very, very excited about that. And so through this collaboration, we not just make it easy for customers to build their own AI, but also we make it more cost effective. And so with Inferentia, with Trainium, you can use them directly with Hugging Face models. We build open source to make it easy for you to do that. On the marketplace, there is machine image and AMI that's available for you to set up your own workloads.
And Wasim, how has, the same question to you, how has this partnership helped Writer? And any comments on that?
I think the biggest thing you can notice when you partnership with AWS in general, they understand actually that technology is not just a software and documentation. You go figure it out by yourself. Like HyperPod itself as a system is not that complex to implement, but it's still a new technology. So I remember the early days when we introduced HyperPod, the team actually was with us for online and Slack, we have on the call, a few times in a day if it's required, to train the engineer to utilize them to actually use the tools. And that actually help a lot. So you feel as that's a product and you use it. It feels actually true partnership. You actually care about really utilizing the system, implementing and training. And that not just, I mentioned this, the HyperPod, this is our recent experience, but that's across other services also. So appreciating, the partnership with AWS in general, and to appreciate the understanding that regardless of the company size, big or small, they still actually care for those details.
And Robert, how about yourself?
Yeah, the partnership with AWS honestly has enabled us to do what we're doing. Without AWS, we wouldn't have, we start with snowball devices that get loaded with data, moved into S3, de-identified at scale through Spark jobs and moved to the compute clusters in whatever region they reside, down to being able to move that data onto FSX, move that onto our cluster, be able to train at scale. It's really everything across the entire spectrum that's kind of enabled us to be able to accomplish what we have with a relatively small group of engineers. So the partnership's been fantastic from a technical perspective. From a support perspective, we have great partnership there. Being able to get unblocked when we run into any issues, and even from a strategic perspective, and just kind of collaborating with us to understand where are we going, what are the pain points that we experience, and how can we provide feedback to iterate on on the services that we're leveraging.
Great, thank you. With that, we're almost at time, so I want to take some time to thank all three of you for coming today and talking to the audience. I also want to open it up for any Q&A. We will be here for, I think, the next 5 minutes before the next session starts. So if you want to come on over to the podium to ask any questions that you have or just chat with us, please feel free to do so. But thank you all for attending this session, and thanks to our panelists for taking the time to talk to us.
Thank you.
Thank you.